So in this lecture, we will start the vertical circular motion, right? Vertical circular motion. It is also very important or interesting topic. For example, I will start with some example. For example, suppose there is a pendulum, right? It is released from rest at position A at angle theta. The length of the pendulum is L. If you release this mass M from U is equal to 0, what will happen, you tell? When it is released, it will come down and it will move up. Is it clear or not? It will oscillate in this way. Are you getting or not? So when it reaches to the lowest position, lowest point of its path, so what you have to find? First at B, find first at B, find first the speed, right? The speed. And the second, the tension at point A and the tension at point B you have to find. Is it clear or not? So how to find the speed at point B? First of all, in this question, the conservation of energy we will apply to find the speed from one point to another point, right? Suppose this is the reference, right? I'm writing the solution this side, and when you release from rest an object from length L, and suppose this is the theta, it is released from rest, it will come down and it will move with speed v when it reaches over here. So what is happening, you tell? If we take the reference 0, the h is 0 over here, and what is the height h? What is happening? We will apply the conservation of energy, that all the potential energy, right, is converted into the kinetic energy. Are you getting or not? Or you can say, if this is the A and B, you can apply, what can you apply? The conservation of energy, right? What is the conservation of energy? Conservation of mechanical energy, you can write kinetic energy at A plus potential energy at A is equal to kinetic energy at B plus potential energy at B. Is it clear or not? So if it is released from rest, so the kinetic energy is 0 and the potential energy of this bob is mgh, which is converted into half m vb square plus what is the potential energy over here? If I took this reference, this is the reference, to 0. So therefore the mgh is equal to half m vb square. So what does it mean? It means the conservation of potential energy, that is the potential energy is converted into kinetic energy. So m vb square, it is equal to 2gh is equal to vb square, and the vb can be written as 2gh. Is it clear or not? Right. So now this height we have to find. If this is L, what is this? Suppose this is the x, so I will apply the cos theta. What is the cos theta? Say base upon hypotenuse, so x will be equal to L cos theta. So this distance, if this is L, the base is L cos theta, you will remember, and this total distance is equal to what? Say length L. All right. So what is this height h? You tell. This height h is L minus L cos theta. H may be written as L minus L cos theta. So if I put here, the VB can be found is equal to root 2gh. What is h? L minus L cos theta. So therefore the speed will be equal to 2gl 1 minus cos theta. I think you are getting this. So this is the first part where the speed is asked. Is it clear or not? Right. To find the tension at A, suppose this is the initial speed, UA is equal to 0, right? Here the U is equal to 0. Just it is performing what? The circular motion at this point also. So at this point A, can you tell me how many force will act upon this? Yes, one is mg, another force is what? Tension. Tension is toward the center. Is it clear or not? First of all, direction of the tension is clear, right? And how to resolve the forces along, this is the center of the circle and this is the perpendicular direction. Is it clear or not? So how to resolve? The tension is acting correctly along the radius. No need to resolve this tension. Only this is the mg, need to resolve. This is the mg. Now mg cos theta, and it is what? Say mg sin theta. Is it clear or not, you tell? So what is the net force toward the center at A? What is the net force toward center? Net force toward center. Can you tell? TA minus mg cos theta will provide required centripetal force. Centripetal force. So what is the centripetal force? Say mv square upon r. Is it clear or not? But here what is the speed at A? Say 0. So this is TA minus mg cos theta is equal to 0. So TA is equal to what? Say mg cos theta. Is it clear or not? So this is the TA. Now how to find the TB? When it will reach to this point, how many force will act upon this? Say TG, mg and the tension B. Any other force is acting? No. No other force. So at B point, what will you write? The net force towards center. Net force towards center. What is the net force toward the center? Can you tell? Very good. TV minus mg, and which will provide the required centripetal force. So is equal to mvb square upon r. Is it okay or not? So the TB minus mg, or you may write TB is equal to mg plus m upon r. R mean the radius of the circular track, and the velocity bv we have found, which is equal to what? It is the square. So it will be 2gl 1 minus cos theta. LL will cancel out. So this is mg plus 2mg 1 minus cos theta. Is it clear or not? So I am writing this side. So the TB will be equal to, if you take mg common, 1 plus 2, 1 minus cos theta, and the answer you will get 3 minus 2 cos theta will be the tension at the point B. So this is the way how you can find the tension, right? By simple method, right? Otherwise, some other teacher told, I don't know what they do. They don't tell the net force towards the center will provide the required centripetal force. Is it clear that this is the simple theory, and this is the correct way to solve the questions of the circular motion? Is it clear? Please copy this. Please copy this. This is the very this question is a very important question, and generally we ask in different type of the sheet. Suppose the velocity of the particle, suppose of m is v naught, and now is circular track start over here. Are you getting or not? Like this. So when the body or the particle reaches over there, so the speed will be v naught, right? So what will happen? It will slide down. So it will slide down in this way or not? You tell me. No, it will, listen, when it will move up to some point, it will be in the contact, and then after that it will continue to move in this way. It will never move like this along the circumference, right? So its path will be like this. So up to this point it will be in the contact, and after that it will leave the contact, it will hit the ground at somewhere in this point. Do you understand or not? So in the question, what they are asking at what angle from the vertical it will leave the contact. Is it clear or not? So to find the angle theta where it leaves the contact, what we do, suppose this is the M, this is the point A initially, and at point B, when it reaches at over there, the speed become VB. Here the speed is VA. First of all, by conservation of energy, we have to find the speed at this point. Is it clear or not? So can we find? Yes, we can find. If we take, this is the lowest point, is the reference right, for the potential energy. So here the H is equal to 0 and this is the H. So the kinetic energy at A plus potential energy at A is equal to kinetic energy at B plus potential energy at B. Is it clear or not? You tell. Apply conservation of mechanical energy. Apply conservation of mechanical energy. Is it clear? So what is the kinetic energy at A? Say half m v naught square. What is the potential energy? Say mgh. What is the kinetic energy? Say half m bb square. What is the potential energy? Say mgh. And it is the reference, so it becomes 0. Is it clear or not? Very good, very good. So the m will cancel out and the v naught square plus 2gh is equal to vb square. So we have to find this h. Again, if suppose this is the radius, this is the radius. What is this distance? Can you tell me? If this is the radius, what is the base distance if this angle is theta? Tell. This distance, if this is r, this is r cos theta. And this total distance is what? Say r. So what is the value of h? Say r minus r cos theta, right? So vb square, first of all, we will find 2gh, and in place of h, I will put r minus r cos theta. So vb is equal to root over v naught square plus 2gr 1 minus cos theta. This is the first step to solve this question, right? Copy this. Copy. You tell me how many forces will acting upon this. Leave the question, just tell me how many forces will act upon this. Very good. mg normal and nothing. mg is applying by the earth, normal is applying by the surface. That's it. And this particle is performing at this point the circular motion. So how to resolve the forces? Along the radius and perpendicular to the radius. So normal is perpendicular to the radius, no need to resolve this. If this is theta, this is theta. So this is what? Say mg cos theta. And this is what? Say mg sin theta. So you tell me what is the net force toward the center? Net force towards center is equal to centripetal force, right? What will I write? Say mg cos theta minus nb, right, at this point. nb is equal to centripetal force. Is it clear or not, you tell? Right. What is the condition to lose the contact? Tell me. What is the condition to lose the contact? No. Listen. If this is in the contact, so what until it will be in the contact, when there will be the touch, the pen and the hand, that is the normal reaction will be there. If it is losing the contact, it means the condition to lose the contact mean n becomes 0, the normal reaction becomes 0, right? So what is the condition? This normal reaction becomes 0. Therefore mg cos theta must be equal to mv square upon r. This is the condition to lose the contact. Will cancel out. So rg cos theta is equal to what? Say vb square. Is it clear? And what is the vb square? This is the vb square, v naught square plus 2gr 1 minus cos theta is equal to rg cos theta. Is it clear or not? And what is the v naught value? It is 0.5 root 0.5 gr, I think in the question it is given, right? Root 5 0.5 root gr, right? So if it is 0.5, v naught is equal to 1 by 2 root gr. If I make the square, it will be 1 by 4 gr plus 2 gr 1 minus cos theta. Is it fine? And this is gr cos theta. So gr will cancel out. This is cos theta, 1 by 4 plus 2 1 minus cos theta. So 1 by 4 plus 2 minus 2 cos theta. It is cos theta. It comes this side. 3 cos theta is equal to 9 by 4. So cos theta is equal to what? 3 by 4. Theta is equal to cos inverse 3 by 4. is the answer. So after this angle, the particle or the block will leave the contact. This is the condition to lose the contact. Is it clear or not? Here, any doubt you want to ask in this question, please tell. Right. Can you read the question number 12 in the same exercise? Any one of you? Hmm. 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 Right. So you can check the alpha is the angle from the vertical and the beta is the angle from the horizontal. So according to the question, the particle start from rest over here, right? The initial velocity and zero. So when it will come down, so it will come down when it reaches to the point B, right? It will acquire some velocity, no doubt. And at point B, the particle lose the contact, then you have to find the relation between alpha and beta. So how to solve this question? Again, I will assume this is the reference, the height is equal to 0, this is the height, right? Wait for 1 minute. If I will take this the reference and this the height is equal to 0 and it is the height h. Is it clear or not? Now, first our work is to find the velocity b applying the conservation of mechanical energy. Suppose this is the r. If this is the r, what is this height? Can you tell? This is alpha. R cos alpha. Very good. If this is r, what is this distance? You tell. If r sine beta. This is r sine beta. Right? This is the question. So, what is the decrement in the height? The h is what? Say r cos alpha minus r sine beta. Is it clear or not? Yes. Right. So, applying the conservation of mechanical energy, apply conservation of mechanical energy at A and B. At A and B. Kinetic energy at A plus potential energy at A is equal to kinetic energy at B plus potential energy at B. So what is the kinetic energy at A? Say it is 0. What is the potential energy? Say mgh. What is the kinetic energy at B? Say half mvv square. And what is the potential energy? Because it is 0. Are you getting this concept or not, you tell? So the decreasement in the potential energy is converted into the kinetic energy, right? So the Vb square is equal to 2gh and the h is nothing but 2gr cos alpha minus sin beta. This is the value of the Vb square we will use in the expression. Is it fine or not? Right. Now, what will we apply? Again, we have to lose this block or the ball, lose the contact at this point. So again, we have to write the forces. How many forces are acting? mg and the normal. Right. So normal is acting in the correct way. Only the problem with this mg. If this is beta, 90 minus beta, it is beta. Is it clear or not, you tell? It is beta, 90 minus beta, it is beta. All right. So this is mg cos beta. And what is this? Say mg sin beta. Is it fine or not, you tell? So what is the net force? Net force towards center will provide required centripetal force. Is it clear or not? So what is the net force toward the center, you tell? mg sin beta minus nb will provide mv square upon r in this case. What is the condition to lose the contact? Normal reaction becomes 0. So mg sin beta must be equal to what? M upon r Vb square. The value of Vb square is 2gr cos alpha minus sin beta it is. Right. So r will cancel out. This r will cancel out. Mg will cancel out. So sin beta will be equal to 2 cos alpha minus sin beta. So this is 2 cos alpha minus 2 sin beta, and this sin beta come this side, it become 3 sin beta is equal to 2 cos alpha. So this is the relation between alpha and beta, so that this block leaves the contact at this point. So this type of the concept in the vertical circular motion we can apply to find different condition according to the question. Now I will explain the critical condition to complete the circle and the vertical circular motion, right? What critical condition, right? Critical condition to complete vertical circle, right? Vertical circle. For example, listen one thing. If this is the this is the pendulum of the mass m length L, if you give the speed v, so what will happen? It will move to the some height, right? And it will rest, it will stop, and it will come down. If you increase the velocity, what will happen? If you increase the velocity, it will move to the more height, right? It will come down. If you give more velocity, if you increase the velocity, it will move up to this height and will come down. Increase the velocity. So you have to give the velocity at the lowest point so that it can complete the circle, right? The question is what? You have to find the minimum speed at the lowest point. Find v minimum at lowest point, so that the particle or the bob can complete the vertical circle. Is it clear or not? This is the question, right? So listen one more thing. So what is the condition? You tell me, what is the condition so that it can complete the vertical circle? What is the condition? Can you tell me? The condition to complete the vertical circle, when it reaches to the highest point over there, right? Suppose this is the point A, it reaches to the point B. So when it reaches to the point B, what is the condition to complete the circle? Can you tell me? If this is the VA, this is the VB, any one of you? Okay, listen one thing. If you give so much velocity so that it just reaches to the highest point, is it clear or not? And velocity becomes 0, then what will happen, Newton? The velocity becomes 0, it means it becomes rest, so it will come down like this. Are you getting or not? The string will be slack and the particle will come down at this. It will not able to complete the circle. It means this is not the true that the velocity must be 0, right? You have not to reach the point up to this point only. If it reach at this point and the speed becomes 0, what will happen? It will come down, it will fall down. Are you getting or not? So what is the condition to complete the vertical circle? Listen one thing, I am telling you. How many forces, suppose it is moving in a vertical circle. Are you getting like this? Suppose it is moving. This is the maximum speed over here. When it will move up, the potential energy increases and the speed decreases. So this is the minimum speed first of all at the point B, you must understand. And how many forces will act upon this? Suppose the tension is TA. Yes, the mg and the tension supposed to be. Are you getting? And the speed supposed to be b. The condition is not that the VB must be 0. First of all, it must be clear. Otherwise, it will fall down. It will not able to complete the circle. So at this point, at B, you may mark this is the B. How many forces? What is the net force towards center? Will provide centripetal force. Very good. Mg plus Tb is equal to mvb square upon r. Is it clear or not? Now, what is the condition to complete the circle? Complete the circle. What is the condition? Condition is this tension. Listen one thing. To complete the circle, the condition is that the tension Tb must be greater than 0. Always there must be some tension at the highest point. If there is a tension, then it means it is moving. Is it clear or not? Is TB must be greater than 0. This is the condition. The condition is not the velocity is 0. No. The tension is that there will be no slack in the string. There must be some tension. So TB must be greater than 0. From here, what is the value of the TB? The TB is mVb square upon R minus mg must be greater than 0. From here, the TB value we have put. So the mVb square upon R is greater than mg. Will cancel out. So Vb square should greater than root Rg. So Vb must greater than root Rg. So what is the minimum speed at point B? Root Rg. Is it clear or not? So what the minimum speed should be at least? The speed should be at least root Rg or greater than this. Then it is able to complete the circle. Is it clear or not, you tell? Yeah. So the minimum speed required to complete the circle at the highest point we have found. Now by conservation of energy, we have to find the speed as Va at the lowest point. So we can apply the conservation of energy now. Apply the conservation of mechanical energy at A and B. Is it clear or not? How to apply? Right. If we know the speed at V and we have to find this, you take this is the reference, this is the h is equal to 0 and this h is equal to what? Say equal to 2r. Alright. So I will apply the kinetic energy at A plus potential energy at A is equal to kinetic energy at B plus potential energy at B. So the potential energy at A, it is 0, half m Va square plus 0 is equal to half m Vb square. Right, the potential is mgh. And what is the height h? Say 2r. The m will cancel out. The 2, take the LCM. This is Va square is equal to Vb square plus 4gr. Is it okay or not? So the Vb square, the minimum speed at Vb is root gr. So the Va square is equal to, if I take the square root, so it become Rg, right? It become 4gr. So Rg, gr, right? Rg plus 4Rg. Are you getting? So what should be the speed at A is equal to 5gr. So the A is root 5gr. So what is the minimum speed at A? Must be greater than root 5gr. Or you can say at A speed must be greater than root 5gr. Is it clear now? To complete the circle. To complete the circle. Is it clear or not? In this case, can you find the tension Ta and tension Tb for the critical condition? Right. For critical condition. Critical condition. This is the critical condition. Critical condition means the bob is just able to complete the circle. Right. So if you want to find the tension will be the maximum at this point. And as it is moving in the upward direction, the tension become minimum. So this tension is minimum at point B. So if this is the A, the velocity of V, A, for the critical condition, the velocities I am taking root 5gr and the velocity at this point I am taking root gr for the critical condition. This is the mg. So how to do at A? What will you apply? The net force toward the center. What is the net force toward the center? So Tmax minus mg will provide a required centripetal force. So this is m upon r, it is root 5gr. So this is 5g, 5mg, Tmax minus mg. Is it clear or not? So what is the maximum tension? Say 6 mg. Is it clear or not? 6 mg. Right. And how to find the minimum tension at B? You tell. At B. This is the mg suppose. And the tension. What is the net force towards the center? Mg plus T min will provide required centripetal force mVb square upon r. Right. So this is mg plus T min is equal to m upon r. What is the Vb? This is the minimum speed for the critical condition, root gr, so it becomes here, rr becomes 0, mg plus t minimum. Is it clear? So what is the minimum tension in the in this motion for critical condition is 0. Is it clear or not? One more important thing, listen, for this vertical circular motion, when it is performing vertical circular motion, so this is the Tmax and Tmin. The Tmax minus Tmin is equal to what? Say 6 mg minus 0 is equal to 6 mg. Is it clear? This is the very important relation, very important. Listen one thing. This relation we found for the critical relation, critical condition. Critical condition mean we have just given the root 5 gr speed and it will just complete the circle. Are you getting or not? Even listen, if the minimum speed at lowest point, Va at lowest point is greater than root 5 gr. Are you getting or not? What does it mean? If this speed Va is greater than root 5 gr, speed more than the critical speed required to complete the circle, then what will happen? You tell me. If this speed increases, the tension, the maximum tension will also changes according to the speed, and then when it will move up, right, it will have some velocity, the minimum tension will also be changed, right? But if this speed is root greater than 5 gr and it is able to complete the circle, the Tmax minus Tmin always equal to 6 mg, you can find later at your home. For any speed greater than root 5 gr, if you take, the maximum tension will be at the lowest point and the minimum tension will be at the highest point, but the difference is equal to 6 mg, and this difference you have to remember, right? I'm writing one example, they will give you example, they will use the ratio, right? The Tmax and the Tmin ratio they will give is equal to 6:1, right? They will given the ratio, and this equation you will use by yourself, minus Tmin is equal to 6 mg, right? They will give the ratio, the 10 or the 5 or 4, whatever they give, right? Using this you find the Tmax and Tmin, and then you can find the minimum speed also. Is it clear or not? Minimum and the maximum. This is the homework. If Tmax upon Tmin is this, and this you know, this you have to remember. Find minimum speed and the maximum speed. Where will be the minimum speed? At this point will be the minimum speed, and at this point will be the maximum speed. You have to find. Is it clear or not? So this is the question you have to do at your home. Is it okay? Right. Copy this. Copy this question. Suppose this is the critical condition. Suppose the critical condition, right? What is the critical condition? What is the speed over here? Say root 5 gr. Are you getting or not? So when for critical condition, when it reaches the point C, suppose when it become horizontal, so can you find the tension in C? The tension in A we know. For critical condition it is equal to what? Say 6 mg. Can you find the tension at C? Yes. To find the tension at C, first you have to find, this is the A, you have to find the velocity at C, speed at C. So we will apply the conservation of mechanical energy at A and C. How to apply? If I take this the reference, the height is equal to 0 and this height h become equal to what? Say r. Kinetic energy at A plus potential energy at A is equal to kinetic energy at B plus potential energy at C, right? What is the A kinetic energy? Half m Va square. The potential energy at this point will be 0, half m Vc square plus mg into h. The h will be equal to r. So the m will cancel out. So Va square 5gr by 2 is equal to 1 by 2 the Vc square plus g into h. H is the r. right? So 5gr is equal to vc square plus 2gr, and this is 3gr is equal to vc square. Implies that the speed at the point C is root 3gr. Is it clear or not? Okay, how to find the tension Tc at C? Can you tell me, please? To find the tension Tc, the tension is toward the center and other forces acting mg. Are you getting or not? So which force need to resolve? You tell. Very good, very good, very good. So what is the net force towards center? Net force towards center will require centripetal force. So what is the net force towards center? Tell. Normal. Where is the normal? Tension. So what is the net force towards center? Only tension, right? Tension will provide required centripetal force. And what is the value of the centripetal force? Either mv square upon r or mr omega square. But we know the speed vc is equal to root 3gr. This speed is found with the help of the conservation of mechanical energy. The Tc is equal to what? M by r. This is 3gr. So rr will cancel out. Tc is equal to 3mg. Is it clear or not? So sometime they ask, or you have to use as a standard for the critical condition. This tension is 6 mg. This tension is 0. This tension is 3 mg at the horizontal direction. When it is horizontal, 6 mg, 3 mg, 0. When it is moving in upward direction, the tension continuously decreasing. Are you getting or not? That is the thing. So this is the vertical circular motion under tension. The same type of the motion may be under what? Suppose this is the vertical circular track, right? The question you have sent me today, so it can be completed like this. Listen one thing. In the same way, this is the vertical circular track. So listen one thing. When you will give the speed, it will move up, come down. Increase the speed, move to the more height, the come down. Is it clear or not? So the same thing, you have to give the minimum speed at this point so that it can complete the vertical circle. Is it clear or not? In some book it may be written like this, or it may be given the circular track like this only. So just this is the point A. What is the condition to complete this vertical circle? Suppose this is the vertical circle. So the condition is that when it reaches the point B from the point A, are you getting? So this is the VB. Again, you will not say the condition to complete the vertical track is you just give it the velocity at the lowest point, it just reaches to the highest point. If it just reaches to the highest point, the velocity just becomes 0. What will happen? It will fall down. Are you getting or not? So the condition is that suppose the VB is over there, how many forces are acting mg, and by this surface the normal reaction NB is acting. Are you getting or not? The same thing, same concept at B. What is the net force toward the center? Suppose it is moving in this way. It is moving. The speed is VB. The speed is V at this point, right? It is moving. At point V, what is the net force towards center? Will require centripetal force. What is the net force towards the center? Mg plus Nb is equal to Mv square upon R. Is it clear or not? What is the condition? Condition to not lose the contact or to move the vertical complete circle. What is the condition not to lose the contact? Condition not to not lose the contact. What is the condition? Varsha, any Varsha? 0. So this is Mv upon R minus Mg is greater than 0. So Vb must be greater than root Rg. The same condition. Is it clear or not? So the minimum speed the minimum speed must be greater than root rg or must be greater than this, then it is able to complete the circle. Is it clear or not, Varsha? The same thing, only there was the tension must be greater than 0, other there will be the lack in the string, it will fall down. If the normal reaction is 0, it will just fall down, right? Again, by applying the conservation of energy in the same way, I suppose you can find the VA, right? And the VA comes to be equal to what? Conservation of mechanical energy at A and B. You will find the velocity is equal to root 5 gr. I think no need to do the solution. You can do this by yourself, right? Copy this. The same thing. Listen one thing. In the same way, when for the critical condition, what is the speed over here? Say root 5 gr. What is the speed over here? Say root gr. Is it clear or not? When it becomes horizontal, what is the speed? Say root 3 gr. Is it clear or not? What is the normal? Say 6 mg. What is the normal? Say 0. What is the normal? NC, say 3 mg. Is it clear or not? The concept you can apply for the vertical circular motion also on a vertical circular track. For example, suppose the vertical circular track is like this, frictionless surfaces over there. You have to find the minimum h. Suppose the radius of this track is 10 meter, right? The m is released from rest from here. You have to find the height h. You have to find so that it can complete the circle. It can complete the circle. Is it clear or not? Yes, we can do. How to do? Suppose this is the A, right? This is the B. Are you getting or not? So what is the condition to complete the circle? The speed at VB must be greater than root 5 gr. VB must be greater than root 5 gr. Is it clear or not, Varsha? Right, this is the condition. Or sometime you may write it equal to 0, but it is better to write greater than this because they are asking the height. So the height, range of height will also come. So how to do this question? This potential energy will convert into kinetic energy. Is it clear or not, or should I do in some other way? Right, the solution I'm writing, the condition, this is the m, so VB square is equal to root 2 gh. So VB is equal to what? Say root 2 gh. So what is the condition? Condition to complete the circle is VB should be greater than root 5 gr. Therefore, it should be equal to root 2 gh and root 5 gr. So it is 2h should be greater than 5r. The h should be greater than 5 by 2r. Whatever the value of r is given, you can do. H should be greater than 25 meter. Is it okay or not? Listen one thing. So if somebody asks to find the normal reaction, you can do, right? If this is the mg, if they ask the normal reaction at NB, this is mg. What the equation you will write? Tell me at B. What will you write? NB minus mg is equal to what? Say mvb square upon r. So if you know everything, you can find. Is it clear or not, you tell? Listen one thing. If on the circular track, it is moving in this way, it reached to this point. Suppose this is the point C, the velocity is Vc. How many forces are acting? Say mg and the normal C. So what the equation you will write? The normal C is in the correct direction. Suppose this is the theta, this is the theta. So mg has to resolve the cos theta and this is mg sin theta. So if this is the Vc, what the equation you will write now? Tell, what is the net force toward the center? Nc minus mg cos theta. is equal to mvc square upon r. So in this way, the speed Vc you can find with the help of the conservation of energy, and the Nc can be found. I'm just giving the examples, right? I will do the questions also on this basis, right? It is just for the information because the time is over. So that's why the question may be asked to find the normal reaction. In the same way, you will write the equation to find the normal reaction. As we did for every case for the circular motion, net force toward the center will provide required centripetal force. Centripetal force is not a new type of the force, rather obtained by some other forces. Sometimes it is by gravity, sometimes it's normal, sometimes it is by friction, sometimes by tension in the string. Do you understand the concept? So it is enough for today.